Alright, this lesson is about arcs and central angles. We are supposed to tell whether the given arcs are congruent. Alright, if they are congruent, that means they will have the same measure. So, arc JK and QR. So here's arc JK and here's arc QR. Now, for these two arcs to be congruent, not only do they need to have the same measure, but they need to be the same length as well. In other words, if this were yarn, if this was yarn stretching from J to K, would that yarn be the same length if I put it from Q to R? And I'm going to go ahead and say no. So even though they are both 105 degrees, look at the radius. This circle has radius 4. This circle has radius 4.5. So this is a bigger circle. Alright, so a 105 degree arc on a bigger circle is going to be longer. So they are not the same, they are not congruent. So I will say no. So either the circles need to be the same circle or congruent circles. Alright, same radius. So looking at number 2, for example. Now this has a better shot because it's just the one circle, so I don't have to worry about a small circle and a big circle type of a problem. All I need to do is figure out the measure of this angle, which will give me the measure of the arc. Now the key thing here is recognizing that of course AD is a diameter, which means that when we look here we're looking at a semicircle. Okay, so if I'm looking at this semicircle, I know that this is 180 degrees. And I have 2 out of 3 of the pieces of this semicircle. So I know a semicircle is 180 degrees. So if I subtract 42 and 96, that should give me the missing piece. Alright, so if I do that, 180 minus 96 minus 42, that gives me 42. That means that this piece right here is also 42 degrees. So, arc CD and arc AB are both 42 degrees, and they're in the same circle. So, these arcs will be the same size, the same length. So, yes, these are congruent. Alright, how about number 3? Now, here again, even though both of these are 75 degrees, I have a bigger circle and a smaller circle. So a 75 degree arc on a smaller circle is going to be smaller than a 75 degree arc on a bigger circle. So no, these are not congruent. What about number 4? Now again, I have a better shot because there's only one circle. Let's see, arc STV. Okay, arc STV is like this. Okay, here's arc STV. Okay, and now I want to talk about arc UVT. Now arc UVT is like this. Okay, arc U, I'm going to try not to cover the other one up. VT. Okay, so I need to figure out if these two arcs are congruent. Since they're in the same circle, if they have the same measure, then they will have the same length. So they will be congruent if they have the same measure. Now the pink one, or arc STV, that's just 30 plus 90. Okay, so I know what that is. 30 plus 90, that's 120. Okay, so this is a 120 degree arc. Now if the other one is also 120, then they will be congruent since it's the same circle. But that's not going to be the case because, again, look, I have a semicircle happening here. You see that? See that? This is a semicircle. Alright, so with that in mind, once again, I know that this is 180 degrees happening. So if I do 180 degrees minus, minus 30 minus 90, okay, I'm subtracting the two angles that were given. That should tell me how big this third angle is. Okay, so if we do that, we see that the other angle is 60 degrees. So this is 60 degrees. Alright, in other words, arc UVT is 60 plus 90, that is 150 degrees. Alright, so clearly these are not congruent. Alright, one's 120 degrees, one's 150, so no. Okay, how about, alright, so we're switching to something slightly different. Find the value of the indicated variable. Well, we know that the central angle measure and the measure of the arc are equal. So that means 5x minus 6 should equal 84. So if I add 6 to both sides, so that'll give me 5x is equal to 90. And then if I'm dividing by 5 on both sides, alright, 90 divided by 5 is 18. So that's the answer to number 5. Oh, okay. Well, I'm looking at the marking here. See this marking and this marking. Alright, because these are marked the same with a single mark each, that means these arcs are supposed to be congruent, which means that the angles are supposed to be congruent. Alright, so in other words, 6t minus 12 should be equaling 18 minus 4t. Okay, so let's add 4t to both sides to get these variables together. Okay, these are going to cancel out. So this will give me 10t minus 12 is equal to 18. Alright, these t's cancel out. Now let's add 12 to both sides. So that gives me 10t is equal to 30. Now we shall divide both sides by 10. And that tells me that t is equal to 3. So that's the answer to number 6. Again, the measure of the central angle and the measure of the intercepted arc should be equal. So that means 3x minus 17 should equal x plus 5. So let us subtract x from both sides. So that will give you 2x minus 17 is equal to 5. Now let's add 17 to both sides. So that will give me 2x is equal to 22. Divide by 2 on both sides, and you get x equals 11. So that's the answer to number 7. Once again, these markings indicate that the arcs are congruent, which means that the central angles should be equal as well. So that means 13y minus 48 should equal 8y minus 47. Subtracting 8y from both sides is going to give me 5y minus 48 is equal to negative 47. Adding 48 to both sides, that's going to give me 5y is equal to 1. If I then divide both sides by 5, that gives me y equals 1/5. And that's the answer to number 8. Okay, for number 9, we're supposed to show that the circles are similar by comparing radii and circumferences. Alright, it's important to know that circumference is 2 pi r, 2 pi times the radius. Okay, so let's calculate the circumference of each circle. So for this circle, the circumference is 2 pi times 2. So this circumference is 4 pi. Meanwhile, the circumference of this circle is 2 pi times 6, or 12 pi. Now let's make a ratio out of these. So let's do a ratio of circumference to radius. Okay, so if I go circumference to radius, then that's going to give me 4 pi over 2 for the first circle, which of course is going to reduce down to 2 pi. Now, if I compare circumference to radius in the other circle, that's going to be 12 pi over 6, which again boils down to 2 pi. Okay, so since circumference over radius equaled circumference over radius in both circles, alright, they are proportional, which means they are similar. Obviously they're the same shape, but now we know they are proportional. So there you go. Let's do it again right here. The circumference for this one, again, 2 pi r. That is 2 pi times 8. So that circumference is 16 pi. And here we have 2 pi times 5 for the circumference. So that's 10 pi. So once again, let's look at circumference over radius and see how that compares to the other circumference over radius. Okay, well, for this circle, circumference over radius is 16 pi over 8, which equals 2 pi. Circumference over radius over here is 10 pi over 5, which is equal to 2 pi. Okay, so circumference over radius is the same for both. So that tells us that they are similar. Okay, find the circumference and area of each circle. Well, we just talked about the fact that circumference, I feel like changing colors. Circumference is 2 pi times the radius, okay? Which, by the way, circumference is the length. It's sort of like perimeter, when we would talk about polygons, if this was 5 and 4 and 6 and 8 or whatever it was, the perimeter would be what you would get if you added all these up. So it's sort of like the perimeter would be if you had some sort of a rope and you went from here to here with the rope, and then you went from there to there. Now if you cut the rope and stretch the rope out, okay, the length of the rope would be the same as the perimeter. So that's what circumference is, but we're laying that rope obviously in a circle. So if you took a circle and you lined a rope all the way around it, okay, if you broke the rope and stretched it out straight, the length of that rope would be the circumference. Okay, so the circumference is like the perimeter of a circle. Alright, it's not measured in degrees, it's measured in inches, feet, things like that. Okay, anyway, that was a little side background story. The area of a circle is pi times the radius squared. And area reflects the space on the inside. Okay, so the circumference is the border. Okay, I'm not doing a very good job of tracing, but circumference is the border and area is the space inside. Okay, enough background. We're just supposed to calculate right now. So if I want to calculate the circumference of this number 11, I will do 2 pi times 12. Okay, so that is 24 pi inches. Alright, doesn't say anything about decimals, so I'm just going to leave it like that. So there's the circumference. Alright, if I want to find the area, then the area is going to be pi times the radius squared. So that's going to be 144 pi, because 12 squared is 144. Now the units will be inches squared, square inches. Alright, because area is space. So area is measured in how many little squares will fit inside of something. Okay, square inches. So that's it for number 11. Number 12. Similarly, the circumference is, okay, of course, 2 pi r. So that's 2 pi times 14. So that's 28 pi kilometers. Alright, there's your circumference. Now the area, once again, the area is pi times the radius squared. So the area will be pi times 14 squared. So the area will be 196 pi square kilometers. Right? Just put those units on there. Alright, this time they didn't draw us a circle, but we don't need it, do we? The circumference is 2 pi r. So that means the circumference is 2 pi times 13.2 millimeters. That means the circumference is, now since we have a decimal anyway, I think I'll go ahead and just get the decimal. So 2 pi times, what was it, 13.2? Am I remembering that right? Okay, so I'm going to round this to the nearest tenth. So 82.9 approximately millimeters. Okay, yeah. If we wanted to keep it exact, then we could have said 26.4 pi. But to me, it's strange to have the decimal in there and then the pi. You know, I don't know. Oh yeah, that was circumference. What about area? Alright, area is pi times the radius squared. So that's going to be pi times 13.2 squared. So again, I think I will just go decimal for this. Alright, so that's going to be pi times 13.2 squared. So to the nearest tenth, that's 547.4. millimeters. Okay, and if I did want to keep it exact, I'd have to do 13.2 squared separately. So 13.2 squared is 174.24. Okay, and then I could say pi millimeters. I shouldn't leave off the units, should I? Millimeters. Okay, so on a quiz or something, I'll try to be real specific which one of these I want. Okay, and alright. Well, this one is a very slight curveball. We shan't be fooled. We shan't be fooled. They're giving us the diameter, but all of our formulas have radius in it. But we know the relationship between the diameter, alright, which is the length of the chord going through the middle of the circle, and then the radius. So if this is the diameter is 16 miles, all right, let's we're up in an airplane or something, well then the radius, you know, what's the radius going to be? The radius will be half that, so the radius will be 8 miles. All right, that was a movie that had Eminem in it. Let's see, 8 miles. So that tells us the radius is 8 miles. So now we can just ignore the diameter and go on with our formulas. Or I guess I could have considered that another formula for circumference is pi times diameter. Okay, so I could have just kabam gone with that. Anyway, I've already set out on my course now, so I can't turn back. Circumference, I have been talking about as 2 pi times the radius. It is pi times diameter, same thing. But looking at it this way, then the radius is 8 now. So that's going to be 2 pi times 8. So my circumference will be 16 pi miles. Okay, meanwhile the area, which is pi r squared, is going to be pi times 8 squared, so that's going to be 64 pi miles. Alright, if they give you units, you better use them. Alright, that's number 14. Okay, we need to find the radius, so sort of like we're working backwards. They're giving us circumference, so if they give you circumference, start with the circumference formula. Circumference is 2 pi times the radius. So this 62.8 is the circumference, so that goes right here in the formula. So this becomes 62.8 is equal to 2 pi times the radius. So we're supposed to find the radius, so I need to get r by itself. So I will simply divide both sides by 2 pi. Okay, that way the 2's and the pi's will cancel out, and that should give me the radius, my friends. So 62.8 over 2 pi. Okay, that's 9.99. Okay, which would round to 10 if I do the nearest tenth. Alright, so something very close to 10.0 inches. Don't forget your units. Alright, so that was number 15. Okay, how about number 16? Alright, same type of deal. The circumference is 2 pi r. So they're giving me the circumference, so that is c. So this is going to become 114.2 is equal to 2 pi r. So once again, I will just divide both sides by 2 pi. Okay, that way the 2 pi cancels out. Okay, 114.2. over 2 pi. That is 18.2 rounded up centimeters. Okay, there you go for number 16. Number 17. This time they're giving us the area. If they give you the area, start off using the area formula. Area is pi r squared. So if they're giving us the area, then area goes here where it says A. So that's 201.1 is equal to pi times the radius squared. Okay, so we need to divide both sides by pi for sure. Okay, don't actually do it yet, alright, because I don't want any decimals I have to round until the end. So just leave it like this for a sec. So far we have 201.1 over pi is equal to r squared. Now, how do we unsquare things? How do I just get r? You guessed it, I need to take the square root of both sides. Normally we'd have to do plus or minus, but you can't have a negative radius, so we don't have to worry about the minus version. So this is what I'll put in my calculator, the square root of 201.1 over pi. Okay, so the square root of 201.1 over pi. Is that right? Yep. Aha! That is virtually 8.0. Alright, that's 8.000. Okay, so we got a radius of 8.0. Feet. Alright, if the area was square feet, then the radius will be feet. Okay, that's number 17. And last but not least, number 18. Again, if they give you area, start off with the area formula. Area is equal to pi r squared. So they're giving us area, so that goes right here. So that means we have 78.5 is equal to pi r squared. Alright, divide both sides by pi, but don't do it yet. Don't put it in the calculator right now. I don't want any unnecessary rounding. Okay, your answer will be off. So for right now, just recopy it. Now, how do I unsquare this r? How do I get r by itself? Alright, just like last time, I will use the square root. So that's going to give me r. And this is what I'll put in my calculator. 78.5. Okay, and I get 4.998. So if I try to round this to the nearest tenth, I will get 5.0. And we had millimeters squared, so the radius will just be millimeters. And that is the last problem in this lesson. I hope it was helpful to you. I will see you on the next video.